We have another Kubota in the shop. We seem to get a lot of these that are overheated.
Yeah, for whatever reason, it seems like the machinery that these Kubota engines are in are prone to overheating for various reasons.
We see the result of the problem. We don't a lot of times get to do a lot of the diagnosis of what actually caused this.
We know what happened, but we don't have the complete unit here to be able to really diagnose what happened. All we get is a result. And most of the time, the problem is not here. The problem is somewhere else, whether it's, they ran it out of coolant, plugged up radiator. Most of them have something to do with the loose nut behind the steering wheel, but it is what it is. We just go to work and we fix what we have before us. The customer had taken this to another shop, and the shop that is actually the dealer for this piece of machinery said the only thing they would do is supply them with a new replacement engine. And for what I understood, that was over $20,000 for a whole complete unit. So the end customer took it to another shop that is now our customer and said, hey, is there anything you can do with this and save us some money, because we don't have 20 grand in the budget to replace this.
Show us the pistons here.
Well, we've got two here that still look just fine for a used engine, yeah. This one has just a little bit of scuffing started on a skirt there, but then we get to the next two here, and man, this thing is just scored to no end, to the point the ring is stuck. It won't budge. This piston here, same way. It is scuffed real bad here where it tried to tie up in the bore. I can get pistons that are a 0.5 millimeter oversized. Hopefully we can bore the cylinders and make them clean up within that range.
Well, this is going to be so much easier than what we normally do, because you're talking about millimeters instead of inches.
Yeah.
And from the comments we get, I hear that when you're working in millimeters, it's significantly easier than working in inches. So this should be an easy job.
Maybe if you grew up in the metric system. Those of us that grew up using inches, usually an engine that's overheated, you see more damage in the center cylinders where the heat is more concentrated. But this one, it's actually, what is that? The front two cylinders are the worst. And the back two are the best. So hopefully, even though we're not diagnosing the problem here, hopefully the shop that brought this to us
figured out what
will figure out why this looks like it looks.
But they really don't look too bad.
No, that one, it has a little place where it tried to maybe pull just a little bit metal on the side there, but I don't think it's that big a deal. Yeah, this one you can still see kind of the machining marks in the face of the bearing, virtually brand new.
Even on the cylinders that tied up, the rod bearings look relatively perfect.
Yeah, but it sure made a mess out of the pistons.
And the small end isn't tied up or anything. Probably gonna have to bore the block, deck the block, probably surface the head, do a valve job, polish the crank, pin bushings in the connecting rods.
Well, my concern there may not be necessarily because of the wear, but I wonder, since they've been so hot,
if they come out or something.
So remember, everybody, the arrow is pointing towards the factory numbering on the rods.
And the new pistons won't have arrows. Why'd you choose these clips? There is some blue on the pin.
Oh yeah, that's been hot. Look at the inside of that bushing. Now, when I ordered the kit, it said you had to order 2 bushings for each rod.
That is 2 separate bushings.
2 separate.
So rather than be thick enough to have a groove in it, they
push one bushing in flush on each side, and then it leaves a groove through the middle for the oil. Back in the 50s, I suppose is when it started, maybe earlier than that, the Waukesha engines that were used in Oliver tractors had bushings like that. And they don't stay in.
They don't.
No,
there's not a lot.
They had trouble with them coming out. So at this point in time, the replacement bushing is one complete solid bushing.
But yeah, that bushing, it's all blue, black, burnt. The pins do look like they've been a little hot.
Yeah, very hot.
Because yeah, the crank looks pretty okay considering.
It's almost like the gasket has worn into it just a little bit. I don't know if we'll be able to get new seats or if we'll have to use universal seats. Okay, 32 keepers, they are accounted for. Really not seeing anything unusual there. It's pretty dirty on the intake side. I think this thing, they might want to look at the intake system on this. There's a lot of stuff in there that just kind of seems like dust. They do have positive seals.
Honestly, I think the valves wore pretty good. Like,
Just
or not.
normal
Yeah.
wear.
This exhaust has a little bit of pitting, but there's not a massive groove worn in it or anything like that.
Can you see on the stems, are they still the black nitriding showing, or are they worn through that? Yeah, that one is. Yeah, that one definitely is. Is that intake or exhaust?
That's an intake.
Which would go along with me thinking it's been sucking some dust in.
Yeah. There's not like a lot of signs of a bunch of heat in the head, so that's good.
No. So we'll get it in the oven here and bake this, burn all that carbon out of it, blast it.
All right, so it's the next day after teardown, and we got a lot of this stuff baked and cleaned up, and we actually decided that we're just gonna go with brand new valves in this cylinder head since there was a little bit of wear. I'm just gonna dump those in the scrap here. It's looking like it's about time to head to the junkyard with a lot of this because we've got a lot of scrap piling up, and I'm glad that I have my new pair of Brunt boots to keep my feet safe when we go out there. I'm not really an everyday boot type of person, but Brunt knows that we have a lot of viewers who are blue-collar workers and in the trades here. So they reached out to us and asked to sponsor today's video. And actually, I got my first pair of Brunt boots about 3 years ago. These are the Marin, and you can see that I actually did wear these quite a bit in the shop. Luckily, they are heat resistant, oil resistant, and waterproof. Not all of their boots are waterproof, but some of them are. One of the great things about Brunt boots is that they are comfortable from the very first time that you put them on. This pair of boots feels just as good as this pair of boots does that I've worn for 3 years. And again, I don't wear them every single day, but we're moving into the winter months here in Colorado. It's gonna be snowy, and there are instances like going to the junkyard with our scrap metal that I do wanna keep my feet super safe. We know that there are a lot of you who work in trades where you have to have safety rated boots every single day, and that's where Brunt workwear comes in. They have slip, oil, and heat resistant outsoles up to 572 degrees Fahrenheit, which is just kind of crazy. We had a fire in here the other day. I kind of wish I would have had my boots on to stomp that out. They really have everything for whatever trade you're working in. And the great thing about it is you can try them out completely risk-free. You can actually wear the set of boots that you purchased, and if you don't like them, you can send it back. You'll have free shipping both directions in the United States if you choose to do that. So get $10 off your first purchase today with a risk-free trial by going to bruntworkwear.com/JimsAuto10. That's bruntworkwear.com/JimsAuto10 and use code JimsAuto10. Link in the description. Thank you to Brunt Workwear for sponsoring today's video. Now let's get back to work on this Kubota. So now we can get a pretty good view of the scoring on those two cylinders. The other two don't really have any scoring.
No, they look okay. You can still see here in some of these lifter holes here, the oil is burned on the inside of those. So the block has definitely been hot.
Yeah.
Interestingly, a few months back, we had another customer bring one of these in that the same thing had happened. They had overheated it. It had gotten so hot and scored much worse than this one. And we were actually partway through the job before we realized that in this area between the cylinders here where they're Siamese together, it had actually shrunk the metal enough that it stressed it enough and it pulled a stress crack into the cylinder wall between the two cylinders right across in this Siamese area. We're going to look real close on this one, especially after we make a first cut there and it cleans the scoring off to where we can see what the parent material really looks like.
We already ran the indicator across. I mean, we're within 1,000th probably side to side. And
so let's get the cylinders bored, roughed out, and we'll take a light cut off the deck, because I know when you indicated across the center here, there was some variation.
There's definitely some variation between the cylinders.
Yeah, much more than there was out along the edge of the deck surface.
Hopefully that'll show when we surface it. Our spec sheet has a note here that they want you to bore to 3.956 and 7/10 to 3.957 and 6/10. So if we hit that 3.957 for our finished bore size, we're going to be kind of right in the middle of that tolerance range. Since we're going to be finishing out the cylinders on the cylinder hone, we want to leave a decent amount of material here in the cylinders when we bore so that we have enough material over there. So we're going to kind of aim for this 3.952 to 3.953 range. We've set that here in our micrometer so that we can cut to that rough dimension. This machine is totally manually controlled. There's no CNC on it. So it has this little centering finger that'll go down and kind of indicate off of the existing bore. And as that runs in and out, there's a dial indicator up here. So we adjust the X and Y axis of the table until we're centered up and that dial indicator runs fairly true. So you can see our indicator is running true. People ask about how this cutter stays in the machine because they see us just shove it in. And
well, back inside you can't see, but there's a little detent ball that sticks out in the side where this cutter goes in, and it snaps into this little slot right here. But as I come back, I get to that spot right there, I can feel there's a little bit of resistance. Well, that's where it has to push that detent back, and then I snap on in, it goes into that groove and keeps it from coming out of there. These cylinders are about, what is that, 7 inches long. I'm gonna set roughly 7 inches on the stop, and that'll allow it to bore just a little bit past the bottom. And this arm here will trigger this to raise the head back up out of the engine. So this being the first one, I'm gonna hand feed this down. I'm going to feed down till it just touches the cylinder. You think we're ready?
probably so.
Okay, I'll engage.
It's got about the right ring to it.
Yeah, it sounds good. That first cut, I always like to feed down by hand till it touch off. Just kind of a double check that maybe I didn't read the micrometer quite right.
Looks like it cleaned up, and to the eye, there's not any crack down in there.
You'll see this line here. In our videos, we get a lot of comments from people about, oh, you got a crack in there, and oh, you drug the cutter up through there and left a mark. Yes, indeed. When our cutter stopped and it retracted, it did leave a mark as it came up the side of the cylinder, but it is nothing more than a mark. And as soon as we start honing on this, it will be completely gone. And then I even saw a comment one time that they said, oh, we've seen that's still in there after you get done honing the block. Well, what they were seeing, when you run the bore gauge up and down, the indicator on the bore gauge will leave a line. It's like a pencil mark on the cylinder wall. I think that's what they were seeing.
I mean, it's almost probably not even visible on the video here, but
if I drew some little tiny lines there.
And that will show a little bit on the finished cylinder.
Yeah,
so
it'll show probably more after we hone this than it does right now.
Yeah.
And
doesn't matter.
It doesn't matter.
To our minimum bore size right now, we've got about 3 thousandths to hone. And we're actually probably going at least 3/10 to half thousandths,
Right, half.
bigger than that. So we'll have 3.5 thousandths to hone. We'll let the second cylinder run through here. This cylinder is actually the worst cylinder as far as the scoring goes, but I think we're going to be in good shape. Well, cleaned up at least.
Yeah, I'm happy. Yeah, I like the way those look.
Do you have the rods out?
I do. Whatever oil they had in it just kind of cooked a layer onto it, left it kind of a dark brown color.
When we took it apart, it looked like, I mean, you really couldn't tell that there was that much heat down into this part of the rod,
No.
but it was starting to get hot on the crankshaft too.
This one here, you can see the discoloration comes all the way down kind of into this area. You can see that pin, that should be shiny all the way, and it is just blued. Yeah, it should look like one of those. I mean, that
one's been machined on the end, but it should look like that half of one of those.
Yeah.
So it's definitely been hot.
Yeah. I can feel a little bit of wear, but I'm more concerned that that bushing may come loose in there at a later date. So we are going to change those. Looks good to me. But what do I know? I'll bet anybody out there watching us for this block all know the feeling when you have bored a V8 engine and you get to cylinder number 8, and number 8 is the one that does not clean up at the oversize you went to, and you end up having to do all 8 all over again to the next size.
At least anybody who works in the industry.
Did it clean? That went quick. Let's change the head and see if we can get the surface done. Okay, let's see what it takes. We're thinking 3.
I hear a little bit.
Can barely hear it. I think
Maybe on the rust even.
Yeah, I think where there's some rust sticking up here.
And then let's put some Dicam on it.
Okay.
And maybe do a 1 thou cut, 2 thou,
Yeah,
something light.
Really light, because these are very critical on the piston protrusion out of the top of the block.
Right.
They actually make 3 different thickness head gaskets, so you can compensate for that. Let's just go down 1/1000ths. Well, I wanted to say something to the people out there about that comment I saw about kicking the woolly-faced kid aside and just letting the old man do videos. And I don't think they realize that these videos would not be here, period, if it wasn't for the woolly-faced kid making videos.
Yeah.
They need to appreciate that it takes both of us to make this happen.
Wow.
That just about got it.
But right here we have, in these 2 cylinders were the ones that obviously got the hottest. And
Remember, right over in this area was where that one was scored the worst, and this one was more right in this area.
Yeah. Half
a thousandths or so there, yeah. I think we just take one more because we're fighting for real estate on this. I'd sooner have to make a second pass than take too much off. So there will be 2.
2 total.
2 total, yeah.
1 thou cut. All right.
It cleaned up. We'll have to put the crank in. When we get this done, we'll have to put the crank in and the pistons and rods and measure the piston protrusion and then figure out which head gasket it really needs. But I think we're going to be into the area
Thickest
where we need the
gasket.
thickest one.
Well, next into the hone, I suppose.
Yeah.
We left about 3.5 to 4 thousandths, depending on, where you look here, maybe 3 thousandths to our minimum finished bore size. Our tolerance that we have is about 9-10 thousandths of an inch. So we could actually be anywhere from the 0 on this gauge to almost +1 there. I've got our roughing stones in the diamond hone head here. I've adjusted our belt speeds on the cylinder hone here so that we should get close to a 40-degree crosshatch angle. We have different pulleys up here, so we kind of have fixed, discrete positions of what we can get for our crosshatch angle. It's not quite as adjustable as a modern CNC machine that has infinite variability on the spindle speed and the stroke rate. So we're kind of locked into a couple different spots, and I think that's going to get us our best option here. So this is actually a stop, so it'll stop when it has honed out a certain amount of material. We'll just go kind of slow to make sure we don't crash at the bottom of the cylinder. It gets pretty expensive when you crash because each one of those diamonds costs about $25 plus, and you got to buy 8 of them at a time. You can see up here on the load meter, when it's first started here, we've got quite a bit of swing there back and forth. And that's because after we had bored, we got actually a little bit of taper in the cylinder, because as the boring bar heats up at the bottom of the cylinder, kind of grows and makes the bottom of the hole a little bit bigger diameter. Hopefully once we get closer to our finished size, you'll already see that needle is starting to run quite a bit closer to true. And what that's basically saying is there are less tight spots in the cylinder, and it's just a load meter on the spindle motor to know, how much load it's taking, and the tight spots are hopefully out of it if we're getting a little bit less swing. We'll just let that run for a little bit. I've had to raise the block a little bit because the bottom of the cylinder was actually coming out a little bit tight. So by raising the block, the hone head is actually coming out the bottom a little bit more, and it's overstroking the top a little bit less to hopefully kind of straighten that back out a little bit. It's just little things like that you have to learn how to finesse your machine to get the results that you want. I'm going to run this over here, and we'll start on this cylinder, let the machine run and do its thing, and we'll double check our size and everything. I just changed the pressure in there. It's essentially how often it feeds the stones out. So I ran it a little bit lower. That seems to kind of get you a little bit straighter cylinder sometimes. All right, so I've got this cylinder roughed in as well. Now we're we're just gonna run through all of them and get them all to the same rough size. So, and the machine does its thing. The camera may not pick this up just because of how reflective this is, but on a lot of diesel pistons in particular, they actually stamp the size of the piston and the minimum required clearance. And of course it's in metric, which makes it a lot easier to work on. This piston should measure 3.9526 inches, and our clearance should be 0.1 millimeters, about 3.9 thousandths. So that's zeroed out on a 4-inch standard, 3.952 and 6. Now these are coated skirts, but they've left a bare spot for you to be able to measure at the gauge point. And this one is measuring 3.9524. So within 2/10,000ths of an inch of what the spec says it should measure. And again, the way we're coming out based on the specifications from our engine software from AERA, we're actually going to be closer to 5 thousandths-ish clearance. So we're well within our range of acceptable clearance. We're not going to be too tight and tie up the pistons. Okay, last cylinder here. And now I'm going through These were a 180 grit diamond, so they leave a much coarser surface finish. And we're gonna go in with our 600 CBNs. You know, they'll plateau the surface, if you will, which will give it, it'll knock down, I hate when those fall out. It'll knock down the peaks so that the rings have somewhere to seat. We brought all of our cylinders to our finished bore size, which again, pretty much anywhere between the 0 and the 1 on the left side of the gauge here was going to be an acceptable result. And now we're going to go in and plateau with our finish stones, and that should not really remove any measurable material because it's just taking down those sharp peaks that, you know, on the microscopic level here, because you can feel it feels pretty rough. You wouldn't want, you know, you could imagine how it would tear up piston rings if you just ran it as is. So I'm going to go in here and I'm going to count 12 strokes, and we'll put the profilometer in, see if it looks like it worked or not. It feels much, much smoother than the cylinder that has not been finished out yet. This is what's called a profilometer, and it has a little tiny stylus, they call it, that runs across the surface of the cylinder and picks up all of the peaks and valleys. So here it's measuring. That is awesome for what this application is. And I know these numbers are going to be pretty arbitrary to 99% of the population, but right at 10 microinches on the peaks, 66 on the valleys. So there's going to be a nice deep valley for oil retention there. And our RK41, that's kind of the running wear surface of the cylinder wall there for the piston rings to ride against. So these are all pretty good numbers. And if we can repeat that on the other 3 cylinders, I'll be pretty happy. So just to show there, this was our cylinder that ended up actually a little bit bigger, but you know, when you compare this to what it was before, we've taken almost 0 material out on as far as being able to measure with our bore gauge here. So again, right within our tolerance. So let's go through, do the other 3 cylinders, 12 strokes, and this thing will be ready to clean up and start putting it together. Trying to think of something clever to come up with. I was gonna say it's CNC cocky Nicholas control. Looks pretty. And that's what counts. 3 to 4 tenths past 0. You can see pretty dang straight there, or circular there as well. Curvular. I'm very happy with that. One thing earlier in the video, my dad was mentioning the line that people sometimes see on the cylinder, and that's from the bore gauge running up and down there. It's just the line from running your bore gauge up and down there. So sometimes people see that and they get all worried, but it ain't nothing to worry about. I'm happy with where it came out. I'm confident we're not gonna have any issues with it. It looks pretty and it's gonna run good.
Before we get started on this head, probably the first thing we better do is a quick Magnaflux, because this thing has been quite hot. Would not be surprised if there was a crack somewhere here in the combustion chamber, but appears to be just fine. I have personally had bad experiences in the past with heads that have been overheated. It will shrink the valve seats and you do all your work, you put it back together, and the thing runs about 2 weeks and drops the valve seat out. So regardless of how nice these look to the eye, we are going to take all these valve seats out and replace them. So I've set up a cutter here that I can use to bore one of these, at least one, and we'll see how things go. May just go through and take them all out, but at least bore out one of the valve seats so I can get in there and physically measure what we need to replace it with. There'll be just a little shell of the old valve seat left in there. And I got behind that with my pocket knife and peeled that right out of there. So now I can get inside there and measure and figure out exactly what valve seat this engine will need. Or if I have to put a universal seat in, I may have to cut that just a little bit oversized and put a universal in, see what we have. And it is measuring about 1.240, just in rough numbers, just a little over 1 inch on the inside. And measuring this piece that I took out of there, it's slightly under 1/4 of an inch. And I can get a universal Star Series seat from SBI, our main supplier of this type of stuff. That is 1 inch ID, 1 1/4 inch OD, and 1/4 of an inch deep. I'll have to cut the counterbore of the head out about 10 thousandths to make that fit, but I can put that seat in and do the machine work on it and have it match the original seat in these. So now that I know that and they have them in stock, let's go through and we'll cut out the rest of these. And that one actually came loose. So there we have it. Here we have the next one. These seats feel like a flame-hardened factory cast-in valve seat. They feel like they're hard at the start and then they get soft. Right there, it got soft. All right, let's see if we can do the same on the intake side here. I don't know how they made that material on these, but they are definitely heat treated or some kind of treatment that they are extremely hard on the top side and then they get soft. Nicholas asked from across the shop if these could be as work hardened. And that is a possibility, but I don't think that is what the case is with these. There we go. There we got it. I can tell now that this seat, about 215 thousandths deep. If I get that switch over, which it was probably 5.5 millimeter deep, is what that appears to be. Yeah, 1.417. So I can use a 1.437 or a 7/16, 1 7/16 OD seat by, let's go with 1 3/16 ID, and I'll have to open it up a little bit then. Out of there, there it goes. There. And again, that seat came loose, and that is on the front cylinder, which was the hottest one from the looks of the piston. So I think it's really good idea that we're doing this, because I'm afraid we'd have had trouble with those coming out later had we not changed them. There, that one turned, came loose. Out it comes. Okay, out that one came. There's that one. There we go. There we go. I like to use the old TCM machine here when I do valve seats. Nicholas, he uses the Surdy. Both do equally good job, but I'm just, all the years of using this machine, I still like it the best. And all I'm going to do is go down through, and when I feel it touch off on the bottom of the existing pocket, I'm going to consider it done. So let's see how this works. I believe that's it on the first one. That was easy enough. It is. Let's just keep going the same way. All right, we have all of the intake seats bored to the oversize. Let me switch out the cutter head here. And put just a little bit of oil on the spindle. Feel when it comes down against the existing lower bore. And there we have it. All right, that looks real nice. They're all cut for the oversize.
People love what I did this morning.
Yeah, we've had so many people comment about the mushroom on our drivers that you went to work on every driver we've got and clean them up.
But that's a heck of a lot easier now that we have the lathe.
Yeah.
That sucked to grind before.
Yeah, I used to do those on the grinder, bring them back down. That took quite a little work to do that. Well, that seemed to work pretty well. There they are. We do need to change the guides yet, and I'm going to cut the top side of the guide off so it's flush, and then I should be able to drive the rest of the guide out of the head much easier. So the one thing I almost forgot I wanted to check here is my valve guide height. Be about 325 thousandths. Those are some tough valve guides. Okay, we've got them shortened up. Coming out real easy.
That is a bold thing to say on the first one.
Well, the first 4 went well. What's bold is driving valve guides out with the window right behind.
Yeah.
There they are.
On the day that it finally looks like it might start snowing and you have a hole through your window.
Yeah, it's finally going to get cold like it should be, and we'll have the windows out. So we got the valve guides out at this point, ready to put the new ones in. The intake and exhaust guides are different from each other, so we need to make sure we get them in the right places. So the valve seats on the left side of each combustion chamber, I've marked here, is our intakes. I've got the package of exhausts already open, so let's start with them. Whoops. So I'm going to spray a little bit of lube in each guide opening. And we'll spray a little lube on the guides themselves. And let's go ahead and start the intakes. Okay, I think those are pretty well all started straight. I had you go out to the lathe and make me a little spacer here that is just exactly the height that the top of that guide needs to sit above the head. So I think I can put that on there and then use this little slug here to press that guide down in and use that as a stop.
Okay.
So let's go over to the press. There we have the first one. We'll turn the head around here. Okay, there we have the guides in. The valve guides are semi-finished valve guides, meaning they are about 10,000ths smaller on the inside than what they need to be when they're finished. Most guides we get are already finished to where all you have to do is touch them up just a little bit to allow for, if it crushes in any when it presses into the head. But these being semi-finished, they actually will come out nicer than a finished valve guide, because I'm going to go through here first with a reamer and probably take this to within about 1,000ths of finished size, and then I'll come back with the hone and finish the valve guide to size, but it gives us a very nice, consistent, straight finish inside the guide.
But it's extra work.
It's extra work, a lot more work. Yeah, it's kind of amazing how much extra work it does create, but it shows in the end. If everything went well there, we should have probably 1,000th of an inch left to go for the hone. I'll brush the cuttings out before I try to measure them. And my gauge is set to 0 as final size. So yeah, there's roughly 1,000th. Maybe just a little bit more to go. Okay. Just a few strokes there should get us where we need to be. Good afternoon. Yeah, we're just real close to our 0 there. Just finished up doing the valve guides on this. They're all ready to go. We got our seats in. But we do need to surface this head before we finish the valve seats because we have to have those valves recessed below the face to be in spec. I can't tell you right off what the spec is, but we do have it over there. So anyway, before we can get those valves to that right spec, we're going to have the surface done. I don't think we want to take more than maybe about I'm going to say a 2/1000th cut on this head to begin with. And I'm going to run this on a slow speed as if that would be a finish cut because we might accidentally clean it at that. And we're not in a hurry to go across this anyway because I'm going to step over to the other side of the shop and we will polish the crankshaft while this is making the pass. That's our first cut. All right, we have our crankshaft here out of the Kubota. It looked very nice when it came in. I've now washed it, cleaned it up. I've run a brush through the oil holes. I've given it good visual inspection. I put it between the V-blocks over here on the straightening press and ran an indicator against it. And this crank has less than 1/1000th warpage or run out, whatever you want to call it, on this. Perfectly fine. I'm not going to worry about that. But we do need to mic it. My specifications here on the main journals, 2.9518 to 2.9524, 2.9523. So I'm 1/10,000th under the high side. Rod journal diameter, 2.0857 to 2.0862. Let's see where we're at on those. 2.086, maybe 4. So again, I'm actually a little bit above the high side of spec. This crank was ground very much on the tight side when it was new. 2.0863. So again, just 1/10,000th, actually bigger than they're calling out on the spec. So I think by the time we polish this, that may take 1/10 off of it. I think we'll be in pretty good shape. So I'm going to start out with a 600 grit abrasive belt. I did just a little bit back here on our seal surface. There is a wear sleeve on that. I can see a line on there, a couple of lines on there where the seal has been riding, but there really is no noticeable wear, no measurable wear on there. The gasket set came with a new seal, but it did not come with a new wear sleeve, so we're going to run that existing sleeve there. I'm going to change our belt, go from the abrasive belt to the Scotch-Brite belt. Okay, I'm going to consider that crankshaft to be ready to reinstall. Looks real nice after a fresh polish. I had no reason to think it wasn't fine as it was, but we certainly know it's good now. Blow it off a little bit, make sure there's no dust or cuttings left on it. I believe we are done. And as I suspected, I think 2/1000th has cleaned that head. So let's call that good. I took a valve just like this one here. I figured out where I want my seat to contact that valve. I used this transfer gauge here to determine where that was on the valve. Transferred that dimension over to the 3-angle cutter here on the 30. Got that all adjusted to where now I can come down and cut the valve seat itself. And let's see how things go. I'm going to cut just far enough so I can see all 3 angles on that valve seat. There's a 60 down here. There's a 30 up here that the valve is going to seal against, and just a sliver of the top angle. I'm guessing it's probably about a 15 degree in this case. So now I'll take my valve, and I'm going to put some color on the face of it. Put the valve in the seat, little suction cup on there, and I'm going to spin that just like if I was lapping the valve, but I'm not lapping the valve. There's no grit in between. It just rubs the color, that black color, off the valve and the seat so I can see where they're contacting each other. And since I'd already done a couple others here on that, the first of the video that I started out that I'm not sure if the camera was even recording, I did get my cutter adjusted where I want. I have a 60 thousandths wide valve contact width, pretty much right in the center of the face of the valve. Put my valve back in, and now I need to check my depth because these do need to be recessed in 24 to 31 thousandths of an inch. And you can see as I turn that valve, it does change a little bit because the top of that valve is not machined perfectly true with the face of the valve. But if I can make sure that at no point do I have that closer to the head gasket surface than the 24 thousandths, everything will work just fine. And what I'm seeing there, if I can get a hold of the valve again, my tightest point is about 11. So from 11 to 24 is another 13 thousandths of an inch. I'm going to go back down in, center up one more time. I'm going to come down till I just touch that valve seat again. There we are. I'm going to zero my DRO. And let's take another 13 off of there. There it is. I do have, at my tightest point, 24 thousandths of an inch. So I'm going to call that good. If I move to the next valve seat, I should be able to cut to that same depth, and providing all of my valves are exactly the same thickness, we should be able to just go by the numbers. That one's running 24 and a half, 25 and a half. I think we better stay with that. So what I need to do is number all of those because I want to put them all back in the same position again after I clean the head and assemble it. 7 and 8. And inside on my valve seat, my new seat is just a little bit smaller than what the original factory seat was. So I'm going to go in and I'm going to cut a little bit out of the inside of this seat. Okay, that looks nice now. The inside of the seat has cleaned up. Down inside the port, the seat matches the casting of the port almost perfectly. So I'm going to make all the others the same, and I think our intake seats will be done. think we're ready to move over and do the exhaust valves. Actually, when you kind of run it around there, there's about 36. So I'm happy with that. I believe we are ready to take this head off of there, wash it up, and do the assembly.
So machine work's finished up on the head?
Yeah, machine work is all done. We have everything here new except the keepers and retainers. They're going to be reused from the old parts, but all the valves are new along with everything else that's already in the head. Remember, I did put numbers on all the valves as I finished up the machine work because there is a little difference in the thickness from one valve to another, and I was trying to hit the tighter side of recession spec, so each one is pretty well fit. Needs to go back in the same position again. Okay, those all look good.
Those are kind of a pain with that pin for the
rock. You can tell this thing's been pretty toasty because a lot of these retainers are kind of blued on the top, and I can see blue on some of the keepers.
Yeah. How many cycles do you think that air cylinder has on it? On the
That has a bunch on it.
thousands and thousands.
There we go. Pop these just a little bit. Just kind of make sure everything's seated right. Make sure the springs are down in the pockets where they belong.
All right, so last bit of machine work we have to do on these is the connecting rod pin bushings, which we were kind of at a toss-up of what to do with these because, you know, they didn't feel terrible worn out, right?
Well, no, because I can take one of the pins out of our new pistons and I can put it in that old bushing and it feels fine.
Passes the field test.
Passes the field test. I can put the micrometer on that pin here, measure that pin, transfer that measurement over here to the bore gauge. Right on 0 is my pin size. Okay?
Okay.
So then I can take one of these rods with the old pins or the old bushings in there. You can see they're all discolored from the heat. I can put that on there, measure side to side. I have about 1 3/10. If I measure in the up and down direction, which is the wear direction, maybe 1/5, 1/6, somewhere along in there.
So maybe 2 or 3/10 wear from the way it came from the factory, more than likely.
More than likely. And I can go over here to my specifications. I'm supposed to have from 8 to 16/10 of an inch clearance, and I'm right at that 16 on there now.
Yeah.
So realistically, they pass that inspection, but we're scared of these things because they've been so hot. We're worried that did it shrink these bushings and or shrink the press fit, relieve the press fit, and then we're going to have trouble with these coming out at a later date.
Which does happen. So
it does happen. We don't want that to happen.
So you went ahead and ordered new pin bushings and said, let's go ahead and do it. So walk us through what the process of doing the machine work there is.
The process of that is I would take that rod, put it in a vise like that, and these do use one bushing in from each side. It leaves a groove through the middle because these are pressure oiled up through the rod from the rod bearing down here, and actually has a little piston cooling
Squirts
nozzle
under the crown of the piston.
It's nothing more than a hole drilled in there, but it's a nozzle to cool the piston. So you press those two back in, leave the groove. Well, the process of doing that is I will take the air hammer, and very easily I can get inside where that groove is, and I can drive that bushing out, flip the rod around, drive the other bushing out. Then I go over here to the press with a new bushing, set it up in the press, put a plate on there, press the new one in from one side, press another one in from the other side, and it would look just like the old ones again. And this rod here, I actually had both of them in, but I drove one of them back out, just kind of checking. I wanted to check the bore size of the rod itself. I don't have a specification on that, but it appeared to me that this is, I believe it was 33 millimeter, which would make sense since this is a metric engine. This pin actually measures 30 millimeter, although we're working in inches here just because that's what we're accustomed to, but it was designed.
Well, it was designed to be easy to work on, but we like a challenge.
Yeah, so we changed everything into inches. Yeah, it wouldn't be fun if it was easy. So anyway, I get out these brand new bushings out of the package. This one here, I haven't done a thing to it. And I'm expecting it to not go over the pin, because generally your pin bushings are designed so that you press them in and then you either bore them or hone them to get the correct clearance. Well, I take this thing out of the bag and gosh, it drops right over the pin. In fact, it's sloppy on there. You can, get quite a little play in that. And I'm like, oh man, this is not good. But I'm thinking, well, okay, let's give it the benefit of the doubt. Maybe when that gets pressed into the rod, it will crush that bushing enough to where I will have room to hone it and make it fit. Well, I press that bushing in and pin still goes in, and it actually is sloppy in there.
As far as the feel test, feels worse than
this
the
feels
theoretically worn out.
This feels much worse than the old worn out bushings.
Well, and to be fair, these probably actually aren't worn out. Because they didn't. This isn't an engine that had tons and tons of hours on it. More than likely, it just had a catastrophic heating failure of some sort.
Yeah. So it wasn't worn as such, but it's ruined because of the heat.
Right.
So I have my new bushing pushed in here. Haven't done a thing to it. And we had that other rod on here that we measured, was barely within spec. I put this on there, brand new bushing I haven't touched. And gosh, I've got 1, 2, and I'm guessing over 3 thousandths clearance. I am more than double the maximum allowable clearance on this with a brand new bushing in there.
A little bit out of round.
Yeah, it's out of round, and
which you'd expect. That's why you are supposed to have extra material in there, so that we can either hone it or bore it and get it dimensionally correct.
Sometimes if the bushings are such, you can actually offset bore this bushing to correct any discrepancies in center to center distance, or if you have a block that has been decked a whole bunch and your pistons are coming up too high, you can actually shorten the connecting rod in the bushing to make that right. But here we are. This engine is going to be worse with the brand new bushings than it was with the old bushings.
But if you leave the old bushings in, they might have a real catastrophic failure.
Yeah, because I'm worried those bushings are not going to stay put. I'm worried they're going to come out at a later date. Same way, just like we changed valve seats, on an engine that's been overheated because it will shrink the seats and they come out at a later date.
This is the crap we run into.
Yeah, this is the crap we run into. I called the manufacturer of these parts. Of course, they swear up and down that I am the only person that has had this problem. They just can't understand that. They question my abilities here. I have to explain myself, prove to them I know what I'm doing here. And then they finally come back and say, well, we're sorry, everything we've got is just that way. You're going to have to go elsewhere. So now, do I go from brand A aftermarket to brand B aftermarket and hope they are different?
When brand B aftermarket is known for reboxing brand A's,
exactly,
or vice versa.
Exactly. And you know, this stuff all comes from overseas, probably all comes from the same manufacturer overseas and gets reboxed in a half a dozen different brand boxes once they're here in the States. I ended up contacting the Kubota dealer, and now I have the problem of having to wait, had to air freight in pin bushings from the dealer, or wait. Regular ground transportation would have been a couple of weeks to get them here, but I'm paying the freight to get them in here overnight. And I hope they'll be different. Who knows if they'll be any different, because I have run into this before on Yanmar engines out of John Deere applications where we had exactly the same problem, and those parts were coming out of a John Deere packaged part. Same deal. Bushing was, the brand new one was worse than the old one. So I'm curious, what do you people, you need to leave us some comments. I can't be the only guy that's run into this. In fact, I called our competitor here in town and asked him, oh yeah, I've run into the same thing.
Yeah.
And
well, and your Kubota bushings that are going to come are 4 to 5 times the cost each.
Yes.
Of what the aftermarket ones are.
Yeah. So now,
or you could buy a new connecting rod for $500 each.
From Kubota, that rod, $500.
Which is just a scam.
Yeah, that's all that is. They don't want you rebuilding these engines. In fact, that's why this engine is here already, is because they took it to a Kubota dealer, and the dealer would not even touch it. Said the only way we'll do this is sell you a brand new engine. And my understanding was about $20,000 for it. But then when connecting rods are $500 a piece, it's not going to take long before I've wrapped up more than $20,000 in this anyway.
Yeah. But it makes you wonder if they do this on purpose, because somebody who wasn't a machinist, you know, if somebody was trying to do this in the dirt floor shop that some of our customers build engines in that scares us a little bit, you know, they press that bushing in their home shop and they figure out that pin fits without doing anything to it. They're giddy as can be.
They think that's great because they have now bypassed having to take it to a machine shop, and the manufacturer has bypassed the problem of selling the parts and the customer pushing them in there and realizing the pin doesn't fit, and they go back on the manufacturer and say, hey, what's wrong with your bushings? Well, the bushings are like they're supposed to be. They're meant to be machined. But a lot of times these customers that are the one out there working in the dirt floor, well, if they even have a dirt floor, or maybe if they have dirt, they just don't have the building around it.
They got the floor, they just don't have the roof.
And in the right areas, they do have a shade tree to work under, because that's it. You could push these bushings in, put the pin in, and at least get it assembled, and it would run for how long, I don't know.
Yeah, it's just when we're charging a customer for redoing the pin bushings, we can't be sending out a product that is out of factory specification by double, if not triple, what it's supposed to be.
Yeah.
Because, you know, again, maybe it would run for enough hours that they feel like they got their use out of it, but we can't trust.
No.
I mean, there's tolerances for a reason.
Yeah. And that was the thing this morning when I was calling around on this. One of the salespeople or tech people was trying to tell me that that it's built to the print. And I told him, I said, well, you must have the wrong print then, because that is not how this was intended to be.
And even, you know, maybe we have the wrong spec, but for a pin this size, you don't see 3/1000 clearance.
No.
I mean,
no. And we still have the old rods here to compare it to.
But like you're, you know, maybe on a pin this size, but even, you know, where do you end up on rods?
You know, that's why I was trying to think on some of those Cummins rods we've done here lately. I don't think they're over maybe 2/1000 clearance on a pin that's every bit that big.
Yeah. So it's questionable.
Yeah.
And now here we are, almost end of the week, and you spent all freaking morning calling around.
Yeah, I spent a half a day on this trying to find bushings.
And that's money we lose, because that's hours that you should have been doing labor that we can charge a customer for, but instead you were on the phone. It's always something different.
Yeah. Yeah, this was definitely a twist that I wasn't expecting.
And a little just unfortunate, honestly. So I guess we'll see, you know, those bushings will come in, but we're kind of out of time here on the video.
Yeah.
And, you know, I don't know.
Well, we got done what we can get done. I was anticipating putting the crank and pistons in this block just so I could measure piston protrusion and make sure we had the right head gasket. Since we did change changing pistons, we did deck the block a couple thousandths. So I really wanted to watch that and make sure we was in spec before it left here, but that's going to have to wait.
We're going to just have to see where the time crunch is.
Yeah.
But even so, we'll get it figured out one way or another, even if we have to chase down some other bushings.
Or they may have to suck it up and spend $2,000 to buy brand new connecting rods just because we can't get the right bushings for these. And I really don't want it to turn into something like that. That's not
right.
Our intent here.
Well, it's not right for anybody. It makes us look bad. It makes
the industry look bad.
Yeah, it just all around is not.
Yeah.
It's not great.
So.
Okay, well, let's just take a look at everything else that we got done, because I think all in all, in the end, the customer is going to save at least a little bit of money over a $20,000 engine.
Even if he had to buy $2,000 of rods here, he's still going to save money over the quote he got for a complete brand new engine.
Yeah.
There's a lot of room here to work that.
But your cylinder head is wrapped up.
Cylinder head is done.
Came out nice.
Came out very nice. That's actually, I'm probably more pleased with this than any of the rest of it. And we have our block here ready to go. Cylinders bored, finished. I've got the galley plugs back in that we pulled out to clean it. Yeah, it needs wiped down one more time before it goes in the bag or before we put the crank back in. And the crank is actually still over there in the grinder where we polished it. We did not grind that crank. It's just as pretty can be. They not shut this down when they did, things could have been a whole lot worse.
Yeah, that looks nice.
Yeah, I'm happy with that.
So, alrighty, well, we did our part. We've done what we can for now. Just got to wait on some more parts to come in.
I'm going to let you call the customer and tell them it's not going to get done this week.
No, not my job. This is your customer, buddy.
All right.
Cleaning guy's out here recruiting his own customers.
What's wrong with that? Guy have something to do.
Don't know.